Show by the principle of mathematical induction that for all n belonging to the set of natural numbers, the following statement is true. Okay, let us begin. So first what we'll do, we will suppose that let Pn represent the statement. This is going to be the statement. It's given by 1 plus 4 plus 7 going all the way up to the last term, which is 3n minus 2. And it's given here that this equals half times n multiplied to 3n minus 1. So what we have to do here is we have to show by the principle of mathematical induction, that means for any n value that we consider, that means n is a natural number here, this statement is always true. First we need to verify that this is true for n equals to 1. So for n equals to 1, so what we will see here, that p of 1 will be, so here we have to replace the n value with 1 in the last term. This is the last term here. So we have 3 multiplied to 1 minus 2. And this should be equals to half, because this sum of the terms on the left hand side, that's equals to this expression half times n times 3n minus 1. So all we have to do is replace the n value with 1. Now 3 times 1 minus 2, that's 1. Now half multiplied to 1 times 3 minus 1, so that's 2. So that's going to give us 1. We have 1 equals to 1. And so that tells us that the statement is true for n equals to 1. Now, if it's true for n equals to 1, it will be automatically true for n equals to 2. But instead of verifying that it's true for n equals to 2, we're going to consider a general term. So let's say we are considering the mth term in the given expression on the left hand side. In simple terms, what we are saying here is we're saying that let p of m be true. So p of m be true, where we have m belonging to the set of natural numbers. So here m is a natural number. We're saying that p of m is true. So if p of m is true, that means the new statement will be p of m such that now we have 1 plus 4 plus 7 going all the way up to 3 times m minus 2 equals to half times m multiplied to 3m minus 1. All we have done is replace n with m here. Now, we're saying that this particular statement is true, where m is a natural number. And if this is true, then we need to show that it is also true for pm plus 1. So we need to show that p of m plus 1, so p of m plus 1 will now become, the new statement will become 1 plus 4 plus 7 going all the way up to, so what we'll do here, we have 3m minus 2 already, but we're going to replace this m with m plus 1. So that's going to give us the next term, next consecutive term. So we have 3 times m plus 1 minus 2. Okay, so this must be equals to half multiplied to m plus 1 multiplied to, so we have to replace this m value with m plus 1. So that's going to give us 3m plus 2. So we have to show that this is also true. Now, how do we show that this particular statement is true? Now, what we'll do, we'll start from the left hand side. So on the left hand side, we have the expression, we have 1 plus 4. We're considering the left hand side of pm plus 1, that statement, 1 plus 4 plus 7 going all the way up to 3m minus 2 added to the next consecutive term. So we have 3 times m plus 1 minus 2. So that's going to give us 3m plus 1. Okay, now if we consider the sum of all these terms, this is already a true statement. This equals half m times 3m minus 1. So what we can replace it with, half multiplied to m times 3m minus 1. And to it we are adding 3m plus 1. So let's combine these two terms. We're going to take half as the common factor. So half will get now multiplied to 3 times m squared minus m. Now from 3m plus 1, we're taking half as the common factor. So that means we have 6m plus 2. Okay, so further simplification gives us half multiplied to 3m squared plus 5m plus 2. Okay, now we have a quadratic expression, 3m squared plus 5m plus 2. We can easily factorize it. So it's going to give us half multiplied to m plus 1 multiplied to 3m plus 2. And this is exactly the expression on the right hand side. This is what we have to show, that for pm plus 1, the right hand side comes out to be half m plus 1 times 3m plus 1. So this tells us this, since we can say here, since left hand side equals the right hand side, so now we can say that thus the statement thus p of m plus 1 is true. So if p of m plus 1 is true, then finally we can say that hence the statement 1 plus 4 plus 7 going all the way up to 3n minus 2, that's equals to half times n times 3n minus 1 is a true statement, is true for all n belonging to the set of natural numbers.